Hey, welcome back. Hey, so again, guys, we're still at the flowchart. We're still using this flowchart for doing stoichiometric problems, right? So last time, what we did was we were given moles, so we started right here in this box right here, okay? And then we ended up with moles, which was this box right here. So we only had one step, okay? Right, so we only had stoichiometric problems with only one step last time. And then what we did was we started up with grams, right? We started off with grams, which was this box right here, okay, and we ended up with moles right here. So essentially, there was two uh, conversion factors that we needed to do, two steps to solve the problem right here. So today, guys, what we're going to look at is we're going to look at if the problem now is given moles and we want to look at grams. So let's take an example problem right there. Okay, given is moles, we want to look at grams. Okay, so for example, look at this problem right here. All right. How many grams of Fe2O3 is formed if 1.5 moles of Fe is used up? All right. So again, guys, it always begins with the first thing, find your given. The given is the most important thing that you need to look for. So find the given. Okay. The given, guys, is always the number in the problem. So it's 1.5 moles, right, of Fe. Okay. All right. So look at the flow chart. Where is the given moles? So again, guys, the given boxes again are on the top row. So it's the very first top row. So you look for that. The given moles is right here. So again, we're given moles. So this will be your starting point. So this is where you start. Okay. You're looking for how many grams. So your unknown is grams of Fe2O3. All right. So if you look at the flow chart for that one right there, guys, we're looking for grams. Our unknown is grams. Unknown grams is right here. Okay. And you can clearly see that to get from our starting point to our endpoint. So again, guys, this will be your endpoint right here. You would need to pass through two arrows. All right. So you're going to have to pass the two arrows. This is one, right? And then you got here two, right? So you should know that this problem, okay, guys, has two steps. All right. But before that, remember what we just said last time. If you ever see the word grams, okay, if you ever see the word grams in the problem, all right, you have to get the molar mass. So we need to get the molar mass. The molar mass of who? Whatever formula follows that word grams. So molar mass of Fe2O3. All right. So again, guys, we can Google this. So hey Google, what is the molar mass of Fe2O3? So we can go 159.7. So we'll just go 159.7 grams of uh, Fe2O3. All right. So now look. All right. So we got everything we need to solve this problem. Let's set it up. So again, guys, the setup starts with, again, drawing the boxes in the squares, the quadrants. All right. So let's draw those quadrants again. So always start off with the first two boxes. Again, there's nothing at the bottom. And then the given goes at the very top box. So that's going to be 1.5 moles of Fe. All right. That's where we are. Now, okay. Our first step, the first step, if you look closely at the first step, and what is that first step? It's this one right here. Remember, it has to be in order. First step says there we have to use the mole ratio. The mole ratio is the coefficient from the chemical equation. And again, from where? It's from the given, which is your Fe right there. So 4 moles of Fe. Okay, and your unknown, which is Fe2O3, this one right here. So this is 2 moles Fe2O3. All right, so basically that's it. That's your mole ratio right there. Okay, all right. So So let's put that in. So that goes in here. All right, so who goes on top and who goes at the bottom? You just again look at your given, and that's going to tell you what is going to be at the bottom, because diagonally they have to be the same across diagonally, all right? So since our given is moles Fe, 4 mole Fe will have to go at the bottom, all right? And then here we got on the top, we got 2 mole of Fe2O3, all right? So we're done with the bottom. Let's do the top. Okay, we're done with the bottom and the top. Let's do the second conversion factor, right? Our second step. Look at your arrow. In the second step, it clearly says there inside that arrow, 1 mole goes at the bottom. So just go ahead and put in 1 mole. 1 mole goes at the bottom. Okay, and then the molar mass of the unknown goes on top. So the molar mass of 159.7 grams of Fe2O3 goes on top. All right, since this is the unknown, 1 mole at the bottom is also Fe2O3. All right, so we only got 2 steps. We're done. So we can start canceling out stuff. So the mole Fe cancels out, mole Fe2O3 cancels out, and then that's it. You just need to start multiplying things. So let's multiply everything at the top. So hey Google, 1.5 times 2 times 159.7 is 479.1, goes at the top. Okay. And then the unit will be grams of Fe2O3 over, let's multiply everything at the bottom, but there's only 4 and 1 there, so it's just going to be 4. So we just divide this by 4. Hey Google. Hey Google. 479.1 divided by 4. So this is 119.775. Let's just go 8, and the unit will be grams of Fe2O3. Okay, see that? And that's going to be our answer right there. All right. Now, all right. So now the problem is, guys, what if the given is not moles, and what if you're looking for grams to grams instead? So for example, look at this problem right here. What if you have 2 grams? What if your unknown is in grams and your given is also in grams? So how do we do that? Okay. All right. All right. So let's do this one right here. So let's look at the given. So given. So at the given. Okay. How many grams of Fe is needed if 32 grams of O2 is used up in this problem? All right. So 32 grams of O2. So let's look for that. So again, guys, if you look at our flow chart, 32 grams O2 is our given. Given is grams, so it's going to be right here. So we start right here in this box. Start. Okay. But wait a minute. We said if you ever see the word grams, we have to get the molar mass. So I see grams. Therefore, I need the molar mass of what? Whatever formula follows the word gram. So it's O2. Okay. And what is the molar mass of O2? O is 16 times 2. This gives me 32. Okay. All right. Let's look at our unknown. Unknown. We're being asked for how many grams of Fe. All right. So let's look at the flow chart. Flow chart. Okay. So again, grams unknown is right here. Okay. So that's our grams unknown. So that's going to be our endpoint. Okay. All right. But again, guys, remember I said if you ever see the word grams, and which we see again, we need the molar mass. And again, who? Fe. In our case, hey Google, what's the molar mass of Fe? Okay, let's just go 8 grams of Fe. All right. So guys, look closely at our flow chart. If you look closely at our flow chart, this time we got how many steps? We got 1 going from the start. Remember, it has to be in order, right? So start from the start. There's 1 arrow going away from it. So that's our first step. Okay. Then we have to go down, which means we have to get this as our second step. All right. It's missing an N. Okay. Second step. And then our third step is right here. So this time we got 3 steps to do. Okay. So we got 3 steps to do this time. Okay. So let's set it up. This one's a bit long. So again, guys, the first one is always put in the given and the first 2 boxes. So again, there's nothing here. The given goes to the very top box, which is our 32 grams of O2. All right. So again, guys, we go step 1. So we add 2 boxes. This is our first step. And look at our box for the first step. It says there 1 mole on top. So I need to put 1 mole. All right. And I need to put in the molar mass at the bottom. Now, the question is molar mass of who? It clearly says there the molar mass of the given. So that has to be the O2. So that's 32 grams of O2. Right. Remember, since this is the unknown, I mean the given, they're both O2s. All right. Right. We're good. Now, next we have to go to our second step. Our second step says there, guys, is the mole ratio. Mole ratio between who? Okay. O2, which is this, and Fe, which is this. Okay. So who goes at the top and who goes at the bottom? Again, O2 is going to be going at the bottom. So we're going to go 3 moles of O2 at the bottom. And then we got 4 moles of Fe at the top. All right. And that's our second conversion factor. All right. Let's do our third. Okay. Again, we need to add more boxes to it. Third. Right. If you look at our flow chart, again, it says there 1 mole at the bottom. 1 mole. And then what goes on the top, it says there the molar mass of our unknown. In our case, it's 55.8 grams of Fe. So again, this is for Fe. All right. Okay. Did I have to put in Fe at the bottom? Well, if you don't put it at the bottom, you don't have to put it at the top. Okay. So I just had to make sure that we all know that that was the Fe right there. All right. Let's take out those so we have more space. All right. Let's start solving. Okay. You can cancel out stuff, but again, just remember the last top box is always your final unit. So the mole Fe cancels out. The mole O2 cancels out. The grams O2 cancels out. All right. And how do you do this? Multiply everything first in the top box. So, hey Google, 32 times 1 times 4 times 55.8. Hey Google, 32 times 1 times 4 times 55.8. 0.4, this will be grams of Fe over, multiply everything at the bottom right there. Okay. Hey Google, 32 times 3 times 1. Okay, and that's going to be 96. Right. Hey Google, 7,142.4 divided by 96. Okay, and that's going to be our final answer right there. You see it? All right. Okay, listen to your teacher in class so you can see more practice questions. I'm going to post the other practice questions later on. But again, please make sure you watch closely. Use the flowchart so you know exactly what you're doing. All right. I'm going to post more examples later on. Okay.